All right, welcome, ladies and gentlemen, to a week 5 open Q&A. I hope you guys are doing great. I'm really excited. I got some awesome questions, I believe, and I also saw a lot of you guys are very active in the chat as I got that going on today. Earlier this morning, which it seemed like it just allowed a little bit more people to kind of be a little bit more prepared. So I think that's something that I'm going to be working on as well. I also decided to do a opportunity as far as making a community post, and I saw a lot more engagement off of that. So obviously I'm going to probably focus a little bit more attention on the community post. Obviously, as far as Facebook, if that's something that you're still part of my page and you want to submit some questions that way because you need to show a picture, then feel free to go ahead and do that as well. But I like the community page. And then I do apologize. I see a lot of you guys have kind of put in quite a bit of questions here. And, the reason why I want to try to get things done as soon as possible, because probably about an hour before the stream, I just kind of go through and start selecting, some problems that I'm going to be able to cover, ones that are not going to be too difficult within this grand scheme. It's going to take me too long to explain, but ones that I can, cover at least in this average live stream. So those are the ones that I just kind of selected, and I did receive, some couple of the questions you guys came up with on there. And if I do have some extra time, I will try to do my best for you guys. But what I'd like to do is at least answer these questions because these were previously submitted by students. So therefore, let's kind of go through it again. We're going to deal with kind of got a wide range. We're going to some trig though, definitely some trig. So look into solving the 6 trigonometric functions. We're going to find the amplitude period of an equation. Then we'll work on finding the inverse, which I actually recorded my classroom notes on inverse, so that will be probably coming up here rather soon. Graphing just a linear equation. Then we're going to work on factoring. I think this was actually from one of my videos, and actually it's one of my favorite videos as far as it's how to factor big numbers. And I remember a lot of comments are people were like, how do you know how to do that, and AC method and stuff like that. So the student asked some questions based on my explanation, but I'll also kind of show you some things to think about when you're applying that as far as the factors. And then we'll go ahead and work into solving the cotangent solving equation. Now this one was between negative 2 pi and positive 2 pi, which are basically the same point. So therefore, I'm just leaving these both excluded, so I'm not sure which one was meant to be included or not, because they were shown both included. And then solve a systems of equations. And I guess we can just basically solve that anyway or not. All right, so very cool. See you guys. Oh, geez. A lot of you guys on. That's awesome. So... And what I'll do, guys, is I'll try to go back to the chat as best I can. But obviously, when people are on and they're asking a lot of questions, I do see a lot of you guys have been helping each other out in that chat before I got on, which is awesome. And I really do appreciate you guys helping each other out, being a part of, in this community and doing what you can to, help people out. Because, I think I think if there's one thing that we kind of share is having that kind of frustration at time on a math problem. You've been working on it, you can work on it, and you're just, you're getting so stuck and you just don't know what you're doing. You're just missing. And sometimes it's a very obvious point. And sometimes it's just, something that you needed to remember, or maybe something you haven't learned yet. But a lot of the times it's, I think just working through it and talking with somebody else helps your brain go and remember it. So I really do appreciate you guys posting questions. And then also for those of you that are helping each other out, because I think in the end, that's going to also help you as well. So, all right. So we got Dev, Peach, Bo Rerun, Alina, Tracy, Simon, Andrew, Joseph, Selena, Jose, Deb, Briz, James, Kid Kat, awesome, Peach Princess. Good to see you guys in there. And I really appreciate you guys all joining in. So let me go ahead and get through these questions. I'll let you guys know that this upcoming Sunday, I will probably not be doing my live stream. I'll probably be doing it on Monday just for scheduling purposes. So I'll probably still put out my post on Sunday. That was kind of nice. At least you guys can present it, and therefore at least my community post. And then you guys can paste, make sure you submit in those questions. But it's probably not going to be something until Monday night. I will do another live stream, but it's going to be one of those not question submit live streams because we took our first quiz and this Friday and Thursday. So I'm going to go and review those answers with you guys so you guys can see. For those of you that are at least taking pre-calculus, you guys can get a little familiar with that. And then also for those of you, there's also made some changes with the membership platform. For those of you that are, interested or like the membership, I kind of made some different tiers. That's basically just kind of things for any of you guys that want to support the channel. Obviously, some people, support on Super Chat when they go through. Some people just support by watching my videos, which I greatly appreciate because it's helping you out. But there's also kind of 3 different tiers that has created as far as how I'm going to be providing some of my upcoming videos, as well as the resources, because I create all the resources that I do in class, and I don't share all of those with you guys online. I really just record myself, but some of the things that I know will be helpful to people as far as getting some worksheets and stuff like that. So those are some things that I'm working on, and if that interests you, the members area might have something that you'd be interested in, and that would be great to have your support in that arena as well. But otherwise, that's just want to make a couple of announcements as they came to my head. Let's go ahead and get on to some math. So find the 6 trigonometric functions. Hopefully at this point you recognize the sine, cosine, tangent. Obviously the side that, I'm going to do all these problems. I meant to do them in black and I forgot. So I'm going to have to change this color. I'm going to change this to blue. So I'll do the problems in blue. I meant to type them in though in black and I forgot. So, because usually I like to do my problems in red. All right, so just remember that the side length directly across from the 90-degree angle is going to be your hypotenuse. Here we have our adjacent side. That's the side between the angle as well as the 90-degree. And this is our opposite side, the side that's directly opposite of your angle. So, so the main ones that you need to know, definitely is the sine of theta, the cosine of theta, and the tangent of theta. But when we look at the sine, when we get through these, we got to have all side lengths of our triangle. And we recognize we don't have the adjacent side, right? These are, again, the 6 trigonometric functions are just comparisons. It's how we compare the length of the adjacent side to the hypotenuse, the length of the opposite side to the hypotenuse, or the length of the hypotenuse to the opposite. All these comparisons, and that's really all they are. They're just a ratio, a comparison of lengths. So we got to figure out what the adjacent is. Well, thankfully, we can use good old Pythagorean theorem. And, rather than saying a squared plus b squared equals c squared, I'm just going to use leg squared plus other leg squared equals the hypotenuse squared. So we have x squared, so that's x squared plus 25 equals 36 minus 25, x squared equals 11. Now, obviously, to go ahead and take the square roots, I'm going to do that, and therefore x is equal to positive square root 11, even though when we introduce a square root, we're using plus or minus. Negative doesn't make sense in the context of this problem, so therefore we're going to use square root of 11, or the positive square root of 11. All right, for the sine ratio, that is the opposite over the hypotenuse, the ratio, the comparison, so that's going to be 5 over 6. The cosine is going to be the adjacent over the hypotenuse, and the tangent is going to be the opposite over the hypotenuse. Now, sometimes you might have a teacher or a class or a test that will want you to simplify this, so therefore you can simplify by rationalizing the denominator by multiplying by the square root of 11 on the top and the bottom. And when doing that, you would get 5 times the square root of 11 over the square root of 11 times the square root of 11 is the square root of 121, which is just 11. And a lot of times we'll do this over and over again, that hopefully you'll, at least through that chapter, you get pretty used to it. So then the other, what we call the reciprocal trigonometric functions is the cosecant, the secant, and the cotangent function. And the reason why these are called the reciprocal functions is because they're just the reciprocal. Instead of comparing for sine the opposite to the hypotenuse, the cosecant is the hypotenuse to the opposite. So we're just going to flip them over. 6 over 5. So secant is going to be 6 over the square root of 11. If you kind of follow what I'm doing here, you can see the simplified version is 6 square root of 11 over 11. And then the cotangent is just going to be square root of 11 over 5. Okay, and there you go. Question number 2 says find the amplitude and the period. So there's a couple things we need to understand. First of all, we need to understand we don't really need to understand the amplitude and the period. Amplitude is basically the half the distance from the max to the min of the cosine graph, and the period is basically the length that the graph repeats. Now, what I was thinking though when I say what you need to understand is this trigonometric equation. And this is something that, we've been working in our class as far as transformations of functions. And one of the big reasons why we do that is so students can figure out what all of these values are, the A, the B, the C, and the D. All right, so the amplitude is equal to the absolute value of A. Well, A here is what you're multiplying outside by the cosine. So amplitude actually is not that difficult in this example. It's just going to be absolute value of 2/3, which is 2/3. The period for cosine is going to be 2 pi divided by B. So what that means is we got to figure out what B is, meaning x has to have a coefficient of 1. So this might be a little bit more difficult for some of you to really kind of recognize. First of all, we want the x to be in front. So what I'm going to do, let's write this over here. So let's look at some mathematical ways we can do this. So x minus x over 4. And then I'll show you another way that I just remind a lot of students to kind of do instead. If this, what I'm doing doesn't make sense or it gets a little tricky. I don't want to do this for x. Okay, so let's write over here. All right, so first thing, let's just write the x in front. So I'm just switching them over. Let's rewrite this instead of a negative 1/4. Let's write this as a fraction. So it's a negative 1/4 x plus pi. Okay, now again, for us to find a b, we got to factor this out. That means x has to have a coefficient of 1. So we're dividing out a negative 4, right? You're factoring out a negative 4. And remember, factoring out or dividing out a negative 4 is the same thing as like multiplying by negative 4. So if you were to do that, if you were to factor out this negative 1/4, how much room have I got? Oh, I got plenty of room. This is going to be a minus 4 pi. And again, let's just double check, make sure it works. Like if you distribute this negative 1/4 to the x, you get negative 1/4 x. Negative 1/4 times negative 4 pi is going to now give you a positive pi. Another way you can do this, which I prefer a lot, especially for students that get stuck with here, is just set it equal to 0. Think about if there was no transformations, you would just have x is equal to, like, x would equal 0. And then whatever else is happening, you're just solving. So I would just add the x over 4 to the other side, and then I'd multiply by a 4 on both sides. And then I'd say I'd get 4 pi is equal to x. Well, sorry, I should be careful. That actually is not going to be the best place to do this. That will tell you what the transformation is, which is 4 pi units to the right, but that doesn't tell you what b is. So actually you need to be able to factor that out to really understand the b. Now you could just figure this out from right there, recognizing that that's the b, but technically I really kind of stress with the students getting it into this format, because even though you see the negative 1/4 there, a lot of students will make the mistake in not factoring out, and therefore they'll get the b right, but then they'll make a mistake on the transformations. So I really would emphasize to make sure you go through that extra step. So anyways, we have 2 pi divided by a negative 1/4, and actually the negative, we don't need to include the negative because period is just a length, so negative doesn't really make sense in the context of it. So therefore this multiplied by the reciprocal, and therefore we get 8 pi. And there you go. All right, find the inverse. So we just did this in my class. Just taught this in the last section. So I'm going to kind of breeze through this a little bit. I also just went through my notes here on it. The main thing as far as the inverse, and I saw another question students were not being, some students kind of wrote down, was that, asking how to determine if a function were inverses of each other. So just remember, a function and its inverse are, one, symmetrical about the y equals x line. Their x and the y coordinates are swapped, as well as their domain and ranges is swapped. So all of that understanding, which I spend time using on Desmos, helps us understand to find the inverse. So if I want to find the inverse of this graph, I'm going to use y as a tool to do the math a little bit easier. Since the x and y coordinates are swapped from a function to its inverse, if I want to find the inverse, I'm going to swap the x and the y coordinates algebraically and then just solve for y. And then just, a couple forms that we like here. Here we have x plus 3 divided by 5 is equal to y. you'll use that form. Well, first of all, before I get to that point, so here's y. But remember, we just use y as a tool. So we want to make sure we go back and use inverse notation because remember, we're finding the inverse, right? So we could use x plus 3 over 5. A lot of times you'll see that as, 1/5 x plus 3. Or for like a graphing equation, it might be helpful to have this written as 1/5 x plus 3/5 as like distributed over. So just recognize that those are all the same versions of the inverse. But either way, make sure if you use y, if you insert y to do the math a little bit easier, make sure you go back and insert that as inverse operations. The next equation, g of x, if you want to find the inverse, is going to be again, really finding the same operation. One thing I want you to notice here is I just use inverse operations. I undid subtraction by adding. I undid multiplication by division. So if I want to undo the cube root, I'm going to cube. So therefore I'll have, well, actually, let's just, before I do that. Okay, so we have x and y. So let's swap this. X is equal to the cube root of y plus 4. Now let's go ahead and cube. Doesn't really matter that order, but I just wanted to kind of make sure that we have this. And then I'll just subtract a 4. And then here I'll just insert back g inverse notation. So g inverse of x is equal to x cubed minus 4. Boom. All right, on to the next one. Graph y is equal to 1/2 x minus 5. So it's been a while since I taught Algebra 1, so my explanation of the graphing or where you're kind of at or what you already know is a little off at this point. The main thing, obviously this is in slope-intercept form, so we're looking into y equals mx plus b, where b represents the y-intercept. And remember, the y-intercept is where the graph crosses the y-axis. And m represents the slope. And the slope is basically, that's telling us the kind of change from one point to the next, or a lot of times better known as like the rise over the run. But if we have 2 points, well, let's get the y-intercept out of the way. Right, here's our y-axis, here's our x-axis. So if our y-intercept is at -5, let's go down 5. 1, 2, 3, 4, 5. That's the easy one. Usually the slope is what gives people the difference. But again, remember, a line is made up of infinite many points, and we only need 2 points to graph a line. So we got to find another point. And what the slope is saying is the distance between any 2 points is, 1/2. Basically, 1 unit, a positive 1 unit is the change in the height, and 2 units is going to be the change in the horizontal distance, sometimes called as run. So if they're both positive, we know on the x and y axis, up is positive and to the right is positive. So I can go up 1, to the right 2. But again, also notice that 1/2 is the same thing as -1 over -2. So what that means is I can also go down and to the left 2. And I think that's usually what gets a lot of students from there. A lot of times we call this like the slope triangle. Up 1, oops. Let's do it as a different color. So basically what I was doing here is I'm just following up, down, or I could down and over. But I'm going up, 2, or down and down. But either way, that's going to give you, you either find a point to the right as well as to the left that you can now go ahead and graph the line. And that's the basic idea of it. Obviously, there's more difficult problems that, you'll come across. But, at least the general idea of graphing a line, at least in slope-intercept form, would be to follow that process. All right, so let's go ahead and hit on to my video. So the video that I showed was talking about how to factor with large numbers. And the way that I showed it was called using the AC method, meaning when you have an equation ax squared plus bx plus c, you multiply the a times c. And so the student multiplied, 12 times 15, and we got -180. So, a times c is equal to, -180. Now, I don't know many numbers that multiply to give you -180 off the top of my head. However, I know that I need to find the difference here of -8. Well, one number I do know that multiplies to give me is 18 and 10, right? I mean, that's kind of like, as far as the ones that would be obvious, I'd say 18 and 10 and like 90 and 2. Everything else I'd probably need to just think about a little bit, 90, 45 and 4, looking like that. But, I have to think about them for a little bit. But immediately off of here, I see 18 and 10, and obviously like 90 and 2. Those immediately come to my mind. Well, again, the difference between these two needs to be -8. So negative 18 and 10 obviously works out. But the student wasn't questioning that. But a lot of people have questioned that when I was doing the video, like, how'd you find those numbers? So what the student did is they took those two numbers, let's actually write out like I would do it. So, we'd have, what they have to give you, I forget how to do it, multiply? Yeah. Negative 18 and negative 180, right? What two numbers multiply give you negative 180, but then add to give you a -8, sorry. Okay, so the student's question came in from, all right, I get it's negative 18 and 10, but when you write this using the grouping formula, doesn't matter which order. And my question to them is, did you try both of them and see if they are the same or different? And because the quick question is, no, it doesn't matter, but let's go ahead and verify to make sure that is correct. So if we group the first two terms, we say, all right, what can we factor out of these first two terms? Well, I can factor out a 6b. So by factoring out a 6b, I'm left with a 2b minus 3. Over here, I can factor out a 5, and that's going to leave me with a 2b minus 3. Then I factor out the 2b minus 3, and that leaves me with a 6b plus 5. All right, so now let's go ahead and do this one. So again, if I do the grouping, I group the first two terms. Well, now I can't factor out a 6, but you can see that I can factor out a, a 2. Or 2b. So if I factor out a 2b, I'm going to be left with a 6b plus 5. And then over here, if I group these two terms, again, I'm going to want to factor out a -3. And that's going to leave me with a 6b. So I guess actually I should write that in there. If I factor out the -3 from there, that'll be in the negative, the positive. Yeah, negative 18. So that gives me a negative 18, and then this would be a 6b plus 5 if you factor out a -3. And therefore, again, you can see that the 2b minus 3 times. So what it does do is it just changes the order in your fractions. In your factors. Uh-oh, I forgot to grab my things. I will be right back. Sorry about that, guys. I totally forgot. I was looking at my thing. I was like, oh man, my computer's kind of going a little slow. And I was like, oh no, I forgot my charger in the other room because I was working in here and then I moved to the living room and crap. So sorry about that. But anyways, so that just goes ahead and changes 6b plus 5. Okay, I guess, yes. Boom. There you go. Yeah, so you've... refactor out there. Okay, so the other question that they had was, v to the fourth minus 625, why is it this? And their basically their question was, why is it not this? And I'm not sure what class they're in. That's a plus. So I'm not sure which class they're in, so I can't really answer directly where they're at. But my thinking is they're in a class where they have not involved complex numbers yet. Because here, they did do it right. That is factor down. But here we notice that we can factor this down using the difference of two squares. So here, you can factor that down into v minus 5. So you're just factoring down. So you were right. But you can factor that further down using the difference of two squares. And then also, if we needed to factor it down across, complex numbers, just for those of you that are, needing to practice factoring via complex numbers, then you could factor it a little bit further down. And so typically we always like to write things as our linear factors or linear zeros for when we're finding the rational zeros. So that's why they would practice factoring that down. We don't really factor it down for the complex numbers, but I just wanted to kind of show you in case that was something you needed to do as well. All right, on to the last two. Thank you guys for joining in. I do apologize for a lot of you guys that have, kind of joined into the chat and have not been able to, get to your question. But I did want to let you guys know I will be, taking some more questions definitely next week. I don't think I'm going to be able to add any more questions here for those of you guys that are, that have kind of added some questions to the chat. So I do apologize for you. It just kind of seems like these questions, I guess I decided to choose, were taking me a little bit longer than I was expecting. But we'll do another set next week, and then we'll make sure I put a post in the community tab for you guys to kind of respond to and answer as many questions as I can. The one thing I will ask, please, 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 if you're asking a question, please be specific. That's why I gave you guys the Facebook, post. If you have something you can't really type in, you need to take a picture, send that to me. But it's, I can't really do much with very broad questions. So the more specific, the more problems you guys can give me, that's what I can help you out, or if you want me to explain something, but just give me something off of to explain, not just general concepts from there, because there's just too many questions. There's too many ways I can go about it to go there. So the next one, solve the cotangent of x equals negative square root of 3. So the first thing we gotta do is let's figure out where that solved is just within the own unit circle. So negative square root of 3 cotangent. So remember, cotangent is x over y. And therefore, we need to think of our three coordinate points here. Let's do this one. Square root of 3 over 2, comma 1/2. So x over y, square root of 3. Yep, very good. All right, so cotangent is going to be negative. So here's that coordinate point. Now, if I take my x over my y, I'm going to get a positive square root of 3. But I need to get a negative square root of 3. So therefore, I need to be in the second quadrant, or I need to be in the fourth quadrant. I don't want to be in the third quadrant because that would have been a negative over a negative. So now I just need to figure out what these points are. Well, this point has a reference angle of pi over 6. So therefore this angle, so I'm going to have theta equals 5 pi over 6, because that's pi over 6 short. So it's going to be 5 pi over 6. And then we have this angle, which is pi over 6 short of 2 pi. So therefore, that's going to be 5 pi over 6. So that's going to be 11 pi over 6. All right, but the problem is kind of interesting. It doesn't say find the intervals between 0 and 2 pi. That's what these answers are. It says find the intervals between negative 2 pi, negative 2 pi and 2 pi. Actually, sorry. So here's 0, right? So it basically means between 2 pi going all the way around and negative 2 pi going all the way around that way. So therefore, yeah, we can actually, these answers are in there. Now let's look at this kind of relationship here. And actually, there's a way that we can kind of write this. If you notice you go to 5 pi over 6, if you add pi, that's going to take you to the next solution, which is 11 pi over 6, right? So, and actually it doesn't look like 11 pi at all. So let's fix that. So what I'm going to do is, and you could also reason, if you subtract pi, that's going to take you by there. So what I'm going to do is I'm going to kind of, like, I understand these are my two answers, but what I'm going to do is I want to find all these answers between negative 2 pi and 2 pi. So let's just go from 0 to 2 pi. All right, let's go to 0 to 2 pi and figure out what those are. So that's going to be, well, actually, I already know those answers. So 0 to 2 pi, that's going to be 5 pi over 6. and 11 pi over 6. Now, what if I were to subtract pi? Instead of adding pi, I subtracted pi. Well, that would take me, so this is going to be from negative 2 pi to 0. So here's 0, so I could go down to negative pi over 6. And then I could go all the way around, which would be negative pi, and then go one more over, which would be a negative 7 pi over 6. So therefore, my final solution set is 5 pi over 6. Well, let's do it in order. So we have negative pi over 6, negative 7 pi over 6, 5 pi over 6, and 11 pi over 6. So there you go. So basically find your solutions if, and just kind of find the relationship. A lot of times it's either going to be adding, pi or adding 2 pi to it, unless you have half angles, multi-angles, which is another type of problem. All right, last example. I hope I wrote this one down. KitKat, if you didn't already get to this stuff, please let me know. And then let me know if you didn't already, if I made a mistake here, because obviously I'm going to try to do my best here as far as on these problems. So the main thing is nobody wants to do solving a system of equations with fractions. So the first thing I'm going to do is I'm going to get rid of all of the fractions. But I'm going to treat that for each and every the top and the bottom equation separately. So in the top equation, I'm going to find the LCM of my denominator, or the least common denominator, I should say, of 6 and 3, which is just going to be 6. So I'm going to multiply the top by 6. And then I need to find the least common denominator of 2 and 5, which is going to be 10. So let's just get rid of the fractions first, and then we'll address basically using our any method, either elimination or substitution. So I multiply by 6, and I get, so we're going to multiply everything times 6, everything times 10. So 6 times 1 is 6, that's reciprocal, so that's going to be x. Let's see, that's going to be a minus 2y is equal to 12. 10 here, that's going to give me a 5x. 5 divided by 4, that's 2, so that's going to be a negative 8y. And 10 times negative 2 is a negative 20. All right, cool. So now I could treat this as, all right, should I solve this using substitution or elimination? I would probably prefer, since I have a variable with a coefficient of 1, I would use elimination. I'm sorry, not elimination, substitution. So basically to solve substitution, I'm going to solve for one of my variables. So in this case, I'm going to solve for x because it's rather easy. So I'm basically just going to add the 2y to the other side. So again, if you're here, so I'm just going to take x minus 2y equals 12. Just kind of do it to the side and add a 2y to both sides. All right, and then I get this equation. Well, now in my other equation, I'm going to plug in this 2y plus 12. So in my other equation, I have 5. Instead of writing times x, I'm going to write what x is equal to, 2y plus 12 minus 8y equals negative 20. Okay, then I'm going to go ahead and apply distributive property here. So that's a 10y plus 60 minus 8y equals negative 20. 8y minus 2y, so that's going to be 2y plus 60 equals negative 20. Let's see, subtract to 60, subtract 60. 2y equals negative 80, and divide by 2, y is equal to negative 40. Okay, but again, that's just representing what y is. We need to figure out what x is as well, because when you're solving a system equation, you're looking for the solution for x and y, that the values that are going to make both equations true. So I'm now going to take my y and I'm going to plug it into, or I'm sorry, my negative 40, and I'm going to plug it into the y variable. So that's going to be a negative 40 plus 12. So therefore that's a negative 80 plus 12, and therefore it's going to be a negative 68. Now, if we wanted to write this as a solution point, like a point on the graph where these intersect, because that's what we did. We just did it algebraically, but you could also graph these using graphing technology, and you'd figure that they are going to intersect at the coordinate point negative 6, negative 40, where x is negative 6 and y is negative 40. You could also plug in negative 68 and negative 40 in for x and y, and you would get that to be equal to 2 and negative 2, making both of those equations true. However, that was something I would, for this problem, it's obviously to do, but for the sake of time, we're just going to keep it that we did my work right. But obviously, if I made a mistake, let me know. So, all right, guys, that's going to be, unfortunately, kind of it. I do apologize. I see a lot of you guys, Lucas, Juan, Peach, Luis, Cool Cash, Avenge Mike, Professor, Tara, Laura. So you guys have shown up. I really do appreciate it. And I do apologize. I haven't been able to get to your guys' kind of questions. And yes, I do use Desmos quite a bit. So Peach, why can't you set equals 0, then solve for x or y, then use that number? I'm not sure what Peach is referring to. There's one question. I thought Oh, okay. All right. Well, either way, guys, I'm going to go ahead and finish off the stream for this, but please make sure you guys go ahead and get a look out here. And again, I'll plan on being live again next Monday for your questions, but I will make a post on the community tab on Sunday for you guys to respond, and I'll take as many questions as I feel like I can fit in for a kind of 30-minute slot. So thank you again for joining. I hope this was at least a little beneficial or a little entertainment for you. And again, please continue to help each other out, even if it's in the comments of the super chat or on comments on my videos. I really do appreciate you guys helping out, because me as just one solo, math person, obviously I cannot respond to all the comments I get on my videos, but I do see a lot of you guys stepping in and helping each other out, and I really do appreciate it. I think that's really awesome. So, all right, guys, I hope you have a great night, and I'll see you on the next stream. Cheers.